In this video, we'll talk about area of trapezoids. This video will be a direct extension of the area of triangles and area of parallelograms, so if you haven't checked that out yet, I would suggest doing that first. So let's talk about trapezoids. So a trapezoid is a four-sided figure with one set of parallel sides. So some examples could look kind of like this, where these two sides are parallel. Another example of a trapezoid, it could look something more like this, more the standard stereotypical trapezoid, where again we have one set of parallel sides. Now again, there's some terminology here that I'm not a huge fan of. In a trapezoid, they consider these two parallel sides to be bases. And normally they'll label one B sub 1 and B sub 2. And I like to think of it as, okay, they're the two parallel sides. Those are your bases. And then again, we will have a height. That'll be a factor. So when you're calculating the area of trapezoids, you can either break it up into a parallelogram and then either one or two triangles, or you can use a formula. I will show you an example of both, and the formula for the area of a trapezoid would be base 1 plus base 2 first, then divide that by 2, and then multiply all of that times the height. So essentially you're going to take an average of the two bases, the two parallel sides. And that's worth noting, that's what these are. These are the two sides that are parallel to each other. So let's see what this would look like in practice. We have an example here. We know that the two bases, these two parallel sides, are both 9 and 6, respectively. Okay? We know that the height, because we're looking at this right angle here, is 4 feet. So that's our height. This would be base 1, this would be base 2. Whatever you want to call them, the order doesn't so much matter. So essentially I'm going to have 9 plus 6 divided by 2 times 4. And then I'm going to simplify that expression as much as I can. That'll be the area. So we add up the 9 and the 6, we get 15 divided by 2 times 4 equals the area. Then we're going to divide the 2, we get 7.5 times 4 equals the area. And that would mean that the area is 30 square feet, or feet squared, however you like to write it. Now let's look at this a slightly different way. If I draw a line, and let's go ahead and say this line is perpendicular to the two parallel sides, well then I have a rectangle up top and I have a triangle on the bottom. And I can deduce some side lengths. So the area for the side lengths for the rectangle are already determined. And if I wanted to, I could say this is also 4 feet. And then I just have to figure out what this little chunk is right here. Well, if this is 6 feet and this is 9 feet, well then this must be the difference between the two. So this is 3 extra feet. Because if I'm looking at a rectangle, these two sides must be the same. So if this one is 6 feet, well then this one must be 6 feet as well. So we can look at this as two different pieces. I'm going to find the area of the rectangle, which would just be base times height, or in this case, the length times width since we're talking a rectangle, 4 times 6, which is 24. And then I can figure out the area of the triangle, and this would be 1/2 base times height. So 1/2 times the base, which in this case you could see either 3 or 4. I'm going to say 3 is the base and the height is 4, just so it matches the trapezoid that we talked about in the last chunk. And then we can calculate our area for these two individual pieces. So let's finish off on the yellow one here. We're going to have 1/2 times 3, which is 1.5, times 4, which would be 6. And then, if I want to find the area of the trapezoid, I have to add both of these together. So the area of the trapezoid, I'll do a little a sub t there, is going to equal 30 square feet. Now, whichever method you like, both will work. If you want to break it up into a parallelogram and then a triangle, that's great. If you'd rather just use the formula, that's great too. Whatever one you prefer, either one is totally fine.